Hi, welcome to my channel. I'm here to do my 100 Leetcode challenge. Today we have Leetcode 11, container with most water. Now let's take a look at this question. The word is really long, and then it's good to just take a look at the example right here. Now the input is going to be an array of integer in here, and then the integer representing and corresponding in this graph as a height. So 1 is the height of 1. 8, so now it's 8. So it's in this 2D map, we'll corresponding all the integer in here. And the water that can trap in here, the description is for two lines, which together the x-axis forms a container. What that mean is, for example, in this case, this two line is the maximal water they can trap. And the height of this one is 7, which is here. They can't go over. The water will just leak from here. So they can trap at most 7 as height, and the length between them as 7. So 7 height, 7 width. So the area of this water they can trap is 49. And another example of ignore everything between the first and the last column, and we just assume they don't have anything between. The water they can trap in here to here, the distance from here is 8, and the maximum height that they can reach is 1. So 8 times 1, so the water they can trap in here will be 8, which is way much smaller than 49. So because the 49 is the maximum. So to solve this problem, we can have the beginning like a star pointer pointing to the first one, end pointer to the last one. And then in this case, we have the end pointer here as highest left, and here is highest right. So now we compare left and right. If the right max is bigger than the left max, then we will move the left max forward. And we move that forward until the next one is higher than the left max. Right now it's higher than the left max. They will check. First, they check the left and right first. How many water they can contain. So that's 8, like what we mentioned. Now the left max move to this one. And after this one really high, they will remeasure it. They can, how many water they can contain. Right. But in this case, after they move this one and then do the process evaluation, we'll see if left and compare left max and right max again. So if left max higher than right max, right, and then we'll move the right max. Always move the lowest one to capture as much as possible. Now you see here, right max, there's no need to move to this one. We move, they're looking for something that's higher than them, the right max. If you move to the lower one, the water they can trap is much smaller, always much smaller. So they're looking for something higher. Now they can, the right max, right pointer move to here, left pointer is right here, and then they can evaluate how much water they can get in this case. And then we just keep moving closer from the left and the right until they met each other. Then we'll capture the maximum value that for the water to be contained. So that's the idea of this, and let's make code. So now we have water, start with 0 to keep that maximum water that we can get. And here we have a left pointer equal to 0, and right pointer is equal to height dot length minus 1. So at the end of the array, so while left less than right, so now we need to capture the left max equal to I dot left. Same thing here, right max equal to high dot right. To make this one the edges as the left max and right max until they found the higher one, then they will update it. So now after that, we check equal to max water, and how to calculate how much water we have is right minus left, which is right is here, minus left is this distance right here, time the height, the minimum height. Minimum height of left max or right max. So we track that one. And that's it for this one. After tracking water, and then we can check which one's higher, either left max or right max, which one's higher. So if left max smaller or equal to right max, then we will check, we'll move the left pointer to the next higher, like here, we move the left pointer to the next higher position. So while we always keep left and right, this condition invalid. If you want to move one pointer, you might run out of bound to the right side. So we have to keep left and right always smaller than right. And now we're moving left max. If left max bigger or equal to high dot left HT max, right? Then what we need to do is move the left pointer to the right side, and else. So that means in this case else. So the left pointer is bigger than the right pointer. What we need to do is check the same condition, but now we check right max as right max is bigger than height dot right. Then we keep GHT minus. We move the right pointer to the left side. And after that, you should be able to capture the maximum water that can be contained in here. And last point, we can just return the water. Now it looks like it solved the problem. And let's submit it. Cool. Yeah, this is the idea of this question. So if you have any question, doubts, please comment it below and I will get back to you as soon as possible. And then we see you in the next video. Bye.